So far in Unit 2, most of the equations, when it comes to graphing and analyzing them, they have been in slope-intercept form, which is y equals mx plus b form. We did start a little bit to work with when the equations are in standard form, like ax plus by equals c, and we've done a little bit to manipulate them so that we can rewrite them in y equals. Today, what we are going to do is we are going to start with the equation in standard form. But instead of converting it to y equals form, we're going to go ahead and leave it that way. So your goal is today, I will be able to graph linear functions using the x and y intercepts. We're going to go ahead and use that information to our advantage. Underneath the objective, something a little different, I would like you to graph these right underneath it and be very accurate. I want 1 point on the x line at 2 and 1 point on the y line at 3. What we are looking at in this first graph is the x-intercept. So the x-intercept is this point right here. Intercept means cuts through or goes through, intersects. This is the point where this graph intersects the x-axis. The coordinates of this point are 2, 0. So yes, I would like you drawing the graph. Yes, I would like you labeling this point. On this graph over here, I would like you to draw a second one, a quick graph, so nice and quick, don't spend too much time. Make sure you have a point on the y-line at 4 and a point about between -2 and -3. The title here says y-intercept. So the main point that I'm focusing on is this point right here. This is the point where the graph intersects or cuts through the y-axis. The coordinates of this point are 0 and 4. The reason I would like you to take a moment and have this information down is there's a neat little discovery that is going to make our life super easy. When we talk about the x-intercept, the x-coordinate has a number, and the y-coordinate is always 0. So just to reaffirm that, the x-coordinate is the number, the y-coordinate is always 0. But now, if we talk about the y-intercept, notice the y has the number, but the x-coordinate is the one that is the 0. So the y-intercept has an x value of 0. The x-intercept has a y value of 0. That's going to come into play on our next slide or two, so I just want you to have a visual of why that is the way it is. When you have those two graphs done, go ahead and move to the next page. Here we go. To find the x-intercept, we are looking for where a line intersects. You can choose the word intersects. You can write cuts through, goes through. We are looking where the line intersects the x-axis. And where this line occurs, where it intersects, the y value was 0. So using this little trick we just saw, the way we calculate or find the x-intercept is we're going to sub in a 0 for the y. So now the y is gone from the equation. The only letter that's going to remain is x. So we will solve for the x-intercept. So here's an example of what I mean. If we're going to solve for the x-intercept, we want to keep the x, but the y value is 0. And zeros are lovely because when we sub them in and multiply, anything times 0 is 0. So really, our easy equation to solve is just 2x equals 6. So what number times 2 equals 6? We could divide both sides by 2, and we will find out that x equals 3. That means x was 3 when we subbed in a 0 for the y. So the x-intercept occurs at the point 3, 0. Once we have found the x-intercept, now we need to find the y-intercept. On the beginning of your notes, underneath your objective, when you drew the visual of the x and y intercepts, we talked about the y-intercept is when the line intersects the y-axis. Oops. So when the line intersects the y-axis, its x value was 0. So using that fact, when we want to find the y-intercept, we are going to sub in 0 for the x value. Once we sub in a 0 for the x value, the x is gone, and the only letter or variable left in the equation is going to be the y, so that is where we will solve for y. So here's that same example that we did just prior, but this time we're going to find the y-intercept. So in order to find the y-intercept, we want to keep the y term, but it's the x that we are going to make the 0. So when we go about solving that, we have 2 times 0, which is 0, okay, so we know that anything times 0 is 0, so that whole term is gone. So we are simply left with the easy one-step equation to solve, 3y equals 6. So we're asking ourselves what number times 3 is 6. If you don't want to do it the multiplication way, the opposite would be to divide by the 3. Once we do that, 3 divided by 3 is 1, there's my 1y, and 6 divided by 3 is 2. So we have the y value at 2. So to write that like the coordinates of a point, we made x 0 and we found the y value was 2. So the y-intercept is located at the point 0, 2. Once you have those notes written in that example, go ahead and move on. So now we're going to put all of that together and see why we're doing this. We're going to find the x and the y-intercept, and then we're going to graph using those 2 points. So the first thing we're going to do is find the y-intercept. We're going to find that by making x 0. Remember, once you make x 0, x is gone, and the only letter remaining in the equation is y, so that is what you're solving for. After we have that done, we are going to then find the x-intercept. And we will find the x-intercept by making the y 0, because once y is 0, the only other variable in the equation will be the x, and that's how we find our x-intercept. So let's begin. Notice in blue I have the y-intercept. We are going to make the x 0, but we are keeping the y in the equation because it's the y-intercept that we are trying to solve for. Remember, anything times 0 is 0. So really, 2y equals 12 is the only equation we have to solve. So the way we undo that coefficient is we're going to divide both sides by the coefficient 2. 2 divided by 2 is 1, so 1y is equal to 6. To make ourselves look educated and highly intelligent, we're going to write that as the coordinates of a point, 0, 6. That means x was 0, and we found that y was 6. So if I were to come over here on my coordinate plane, 0, 6 would be the y-intercept. Now, we're going to find our x-intercept. That means we want to keep the x term, but it's the y that we want to make 0. Remember, anything times 0 is 0, so really the only equation we're solving is negative 3x equals 12. Now remember from our previous lessons that when you divide, it must be by the exact coefficient negative 3. And the reason it needs to be the negative 3 is because we want a positive x when we're done. So we need a negative divided by a negative to be a positive 1x. And then over here, 12 divided by negative 3 is negative 4. So we're going to look highly intelligent again. We're going to say that the x-coordinate is negative 4 because we made the y 0. That is the point negative 4, 0. Well, now that I have my 2 points, I can simply connect them. And I know your line will be much straighter and neater than mine. Once you have that example down with the work shown and the graph, go ahead and move to the next slide. So for these next 2 examples, we are simply going to find the x and the y intercepts mathematically. You'll notice there's no graph here. I don't want you to graph them. For the first 2, we just want to practice the actual math part of it. If I'm going to find the x-intercept first, that means I want to keep the x term, but it's the y that I want to replace with 0. And once we do that, anything times 0 is 0. So I simply have negative x equals 8. The number that's in front of this x is actually a negative 1. So go ahead and draw that 1 in there, even though it's not written. We will divide both sides by a negative 1, because now a negative divided by a negative is a positive 1. So there's our positive x equals, and when we divide, we will get negative 8. So the coordinates of this point is the x-intercept is located at negative 8 because we made the y 0. So let's continue and find the y-intercept. That means I'm going to make the x 0, but keep the y term because that's what I'm trying to find, is the y-intercept. Well, negative times 0 is just 0, so really we just have to solve for y equals 8. Divide by that coefficient 4, and we are left with y equals 2. Going ahead and writing that so that we look highly intelligent and proficient, x was 0, y was 2. So the x and y intercepts are located at negative 8 and positive 2. Once you have this example complete, I would like you to continue on to the next one and then unpause the video when you are done so you can check your answers. So how did you do? Were you able to take the time and sub in 0 for the y and then solve for the x-intercept and get 5? So it's located at 5, 0. And then for the y-intercept, did you make the x value 0 and then really just solve the equation 5y equals 15, divide by 5, and you get y is 3. So the y-intercept is located at negative 3. If you missed any part of that, make sure you pause the video and go back and fix those problems, please. Okay, here's our last 4 examples that we're going to work on. We're going to put it all together in one problem. Number 5, we're going to find the intercepts and then graph them. So we're going to put it all together. If I want to find the x-intercept first, I'm keeping the x, but it is the y that I am making 0. So I'm really just solving the equation, negative 4x equals 12. So when I divide both sides by the coefficient negative 4, I end up with x equals negative 3. That means I'm on the x-line at negative 3, because that is located at negative 3 when y was 0. We are halfway done. So now, let's find where the graph intersects or cuts through the y-line. I'm going to take the same equation. This time, I'm going to make the x 0 and keep the y. So now we have 2y equals 12. If we divide both sides by 2, we will see that y equals 6. So that is at the point 0, 6. So now, once we have our x-intercept and our y-intercept, once we have 2 points, we're able to connect them and put the arrows on the end. As soon as you feel comfortable with 5, pause the video and see how you can do on 6. Alright, so how did you do? As you take a moment and look at my work, do you see I did something a little bit differently? Since I knew making the y 0 right here, and anything times 0 would be 0, meaning this whole term would go away, I really just had to solve the equation 3x equals 6. So I did skip the one step of subbing in the 0, and I went right to 3x equals 6. If you need that process of subbing in the 0, please continue doing it. But if you caught on to the pattern that we really just cross out the y term and set the x term equal to 6 and solve, feel free to go with that process. So now to find the y-intercept, we take the y term, negative 2y, and set it equal to 6, divide by negative 2, the y-intercept's at negative 3. And then it should be a rising line with an x-intercept of positive 2 and a y-intercept of negative 3. Take a moment, soak that in, make any corrections you need. The last 2 examples are super easy because the graph is already drawn for you. I am only asking you to label the x-intercept and the y-intercept of the graph. So here is my x-intercept. It is located at 4, 0. And here is my y-intercept. It is located at 0, 3. That's all I'm asking for. So take a moment, look at number 8, last problem for the day. Did you see the x-intercept is right here at -1, 0? And did you see that the y-intercept is located at 0, 1? So yes, I would like you to take a moment and draw a quick graph on your notes. Draw these lines with these 2 points, connect the dots, and then label the x-intercept and the y-intercept. As you go back through your notes and look at them, and you go back to your objective in the very beginning, do you feel you met everything we were able to do? Are you able to graph linear functions using the x and y intercepts? If you feel comfortable and you're good, then you are done for tonight. If you look at it and feel there's a part you'd like to go back and review, feel free to do so.